Hello, good morning, everyone. I am Andrea Ionescu. Let me share my screen and start this session. Okay. So today's session is organized by Astelios Katsifodimos and Andrea Ionescu. We are both from TU Delft. And we will talk about discovery and pricing data in data marketplaces. We're going to tackle its challenges and opportunities. Today's session is sponsored by Operatus Bondi, which builds the first EU marketplace for geospatial data and services called Topio. So Topio is a marketplace for searching assets and trading services. As a user, you have the opportunity to first sell assets, and this is a simple, streamlined, flexible, and secure process. And it only consists of 6 easy steps. When you want to sell assets, you have to register in the marketplace as a supplier. Then you will add metadata for your assets, upload your assets, and finally, you have to select your pricing model and the price and the term and conditions. And that's it. You're ready to publish your asset. Another option is to buy assets. And if you want to buy assets in Topio, you have to register in the marketplace as a consumer. This is also a very easy pipeline. And once you are registered, all you have to do is search for an asset, view, purchase it, and you're almost done. You receive your asset, and all you have to do next is just trust Topio with your purchase. Once you explore and search for the assets, you have the opportunity to see a very comprehensive and detailed view of an asset. And here is where Topio is working very hard on extracting a lot of information about your asset to make it available here for the users so that they can make a very informed purchase. So with this being said, we can say that we are assisting to the rise of the data marketplaces, because the marketplaces are enabling the digital economy where you can search, you can discover, and finally buy the data. Data marketplaces are the key for digital transformation, because having data all for yourself is empowering, but making it available for purchasing will drive the digital economy. But let's take a step back and let's get something straight, because before we can actually use the data, all the data practitioners out there know that we spend a lot of time on discovering, integrating, and also cleaning the data. And with Topio, we want to ease a bit this process, and we want to make it easier available. In today's modern data discovery integration pipeline, the process looks very intricate and complicated. And it takes a lot of steps to get from disparate data sources to your actual assets that you can use it. And talking about pricing and the data marketplaces, how we can actually go from the initial step of having the data sources to purchasing your asset. And this is what we are going to talk about today. We are going to tackle the discovery and the pricing challenges. And we're going to look into some questions such as, how can one explore a data marketplace to find data sets and also their interrelations? And how do I price data assets in a marketplace? Does the discovery process increase the value of a data set? And should this added data value be actually reflected in the data price? You will find the answer to these questions and even more in today's panel, which is moderated by Asterios Katsifodimos, assistant professor at TU Delft. And the panelists are Ziavas Abegyan, a professor at Leibniz Universitat Hanover, Yannis Velekakis, a professor at Utrecht University, and Matteo Alessandrini, an assistant professor at Aalborg University. And now I would like to give the floor to Asterios.
Thank you, Andra. You can see my screen, correct? I assume yes.
Correct. Everything is good.
Okay, good. So I'm going to introduce the panel now, and then after that, I will pose some questions that I would like the panelists to respond to. And after the panelists take a position on the questions, we are going to discuss. I would like to really ask people to ask questions in the chat. I would really like this, and also the panelists. Let's make this more interactive and less sterile. Good. Now, let me just give you some examples of dataset relatedness. Andra has talked about imagine that you have a huge marketplace, you have 1 million datasets, and you want to buy and sell datasets in there. Now, datasets in and of themselves are almost useless unless you have others to combine them with. And what do we mean by that? You can have datasets, for example, with which you can join. Think of it in terms of machine learning. If you have a dataset and you want to add extra features on it, you can simply join it with other datasets and expand your table, for instance, in order to build a more accurate model. Or unionable, meaning you will get more data points, right? If you combine them with the ones that you already have. Let me just give you a couple of examples. Joinable, basically, the joinable relationship is when you have a data set and you simply want to join it with something else. Okay, these are examples of joinable data sets. The first example that you see is relatively simply. Why is that? Because country and CNTR in this case have exactly the same values, and you can simply join them with an actual SQL join. A complicated example of the same nature is to have values which do not really join with SQL. So USA and states represent exactly the same real world entity, but you cannot simply join those. And as we will see, it's also very complicated to find such relationships among datasets in a very big data marketplace. Now, unionable would mean that, for example, you have a bunch of data points and you want to augment them with extra data points to, again, for instance, build a machine learning model that has more data to train. And there are two cases. The simple case is that you will find two data sets of exactly the same schema and you will simply union them. The more complicated case is that you will have two data sets that look a bit different schema-wise, but they do have common columns. Okay, so these are two examples that are, let's say, the most basic and prime examples of dataset relatedness. The question now is, how do we find these relations? Again, imagine a data marketplace of 1 million assets. How do you find those relationships among those datasets? And the answer basically is given by these old database problems of data integration. People have seen those problems for a very long time in the context of databases that you would like to integrate in the past. However, the very same problems, you have to think, have gotten a new life in modern data lakes and data marketplaces. Okay, and it's hard because it touches on a lot of areas of research. Take, for example, schema matching, schema mapping, data augmentation from database research, efficient retrieval, and scoring functions from the search and retrieval research area. And for now, there are no fully automated solutions that work well. Okay, so this is maybe the most important aspect that we would like to discuss in this panel. And why is this very hard? Because Alon Halevi, for example, called this problem to be AI complete, meaning that it does not matter how much you try and you build AI or ML models to do this automation for you, the discovery of the relationships of datasets, because you will always need a human at some point, right? Good. Now, in research, there has been a lot of work in matching methods. And when I mean a lot, there have been possibly hundreds of papers on the subject. People have not compared them for the last 20 years, and that's something we realized 3 years ago. There are no data sets available to be able to do such a comparison, and we do have outdated metrics, which focus mostly on the problems that we had 20 years ago and not on the problems that we had today. To this end, basically, we have done some work at Delft where we do try to implement a lot of algorithms from the past and see what works and in what case. I will refer you to the paper that you see cited here, and I do not need to get into details. But just for the panel to get started, I just have to tell you that dataset discovery and the relationship discovery among datasets is a critical task for organizing any data marketplace and adding value to the existing assets. Now, by value, you may think of pricing as well. So now let's assume that you are a buyer or a seller inside the marketplace. For a data producer, the first thing that they will think when they enter the marketplace wanting to share their datasets is, how the hell do I know the value of my dataset? It may be trivial with commodities in real life, but it becomes a lot more complicated in a data marketplace, which is also extremely hard for the consumers because the consumer does not know how much a dataset is worth. So normally in normal marketplaces, these will reach an equilibrium, okay? Supply and demand will reach an equilibrium. But things get complicated when you can get data sets and combine them with others, and suddenly those data sets gain value. For example, if you have data points about the city, I don't know, about Paris, and suddenly you get another data points about the restaurants in Paris, most probably the value of both data sets will increase simply by the fact that they can be used together and be combined. Okay, so it is extremely important for a marketplace to be able to discover those relationships so that people actually find more value for the data sets that they buy. Now, you might say that just put those data sets out there in the marketplace and the market will prevail. Supply and demand will reach an equilibrium. However, data is not a physical good, which means that data can be copied and shared trivially. So if you sell something to someone, you're not sure whether they have shared in secret, of course, with others. The data gains its value from the analysis that you do on it, and not merely by having the data. And the data will also gain value in combination with other data. So this is not the typical product that we know from normal marketplaces. There are a lot of challenges here, and they are to be solved in the future. So for this panel, and we should start in a minute, basically with our guests kicking in. What makes dataset discovery different from recommendation systems? What do we mean by that? If I give you a dataset, can you find me other datasets with which I can combine my dataset and gain extra value from it? How can one explore a data marketplace to find datasets and their interrelations? This is a research challenge, meaning how can the marketplace itself do the relationship, how can the marketplace itself find the relationships and let the users explore those relationships among the datasets? And on the pricing side, we get all of these nice questions such as, if I clean a dataset, should that cost more than its dirty version? and then how should I sell it? Should I also pay the original data provider? Can I pay for a view on the data? For example, for half of the rows of a table. How should that view be costed? And the question becomes interesting because some rows might be more important than others and valuable, and this will create this inequality in the prices of every row. And should two integrated data sets cost more than the sum of the individual data sets? Or should we just charge for the sum and then add extra value on the analysis? So I went a bit fast. I hope that the questions are clear. I will now ask Yannis Velegrakis, professor at Utrecht University, to take the floor and try to take a stab on these questions. Yannis, floor is yours.
Okay, thank you very much, Staria. And so I have a small presentation that I would like to express my opinion about some of the interesting issues that you have raised. And okay. So I believe the screen is shared now. So what I would like to describe is my position that I think that that there are some interesting aspects on the topics that you have pointed out that have been ignored, and I think that specifically for data marketplaces we have to revisit them. So I remember that when I was a teenager, my parents were trying to teach me how to shop, and they were always telling me, "Do not think what you want to buy, but think why you need it." So I would like to bring this this lesson into this this kind of research about data marketplaces, and emphasize my position that data marketplaces are not actually about the data sets. It's about the service that these data sets are offering. Well, we live in the era of big data, right? So we talk with engineers, entrepreneurs, and big data, big company officials very often. And we never hear them saying, "I wish I had terabytes of data." What we hear them saying is, "I wish I had enough data to be able to infer this kind of information that could help me offer new services and improve my business." So you see that the point is always on the service that can be offered by the data and not just by the data on the data itself. So in order to be able to correctly evaluate the utility and accurately price a data set, we have to reconsider some basic factors, and I'm going to describe these three factors that I consider are important. So the first factor is data quality. It's not a secret that real-world data have many data quality issues. They have missing values, they have outdated values, they have inconsistencies, duplication, or sometimes they are unreliable. Okay, and it has been recognized that bad quality data costs just the US about 3 trillion a year. So when we are measuring the value of a data set, we should not be consider the quality of a data set by itself, looking only at the data values. But what we should be consider is what we can do with this data set, and how much the data quality issues that the data set has can affect the results of the data analytics that we want to apply on this data set. And if the answer is to this question is, for instance, not much, even if we have bad quality data, but the effect on the data analytics that we want to apply on the data set is very few, then I think that the data set should have a high value. So what we had done in the past in the Fitness for Use project, what we did is that we studied this effect by systematically looking at how much noise can change the results of a data analytic task that we have at hand. And by measuring this effect, we were coming up with a factor, and we were using this factor as a metric of the value of a dataset. With this approach, it is possible to measure the data quality of a dataset, even if you don't have the clean dataset. You don't have to clean the dataset. The only thing that matters is how much the data quality issues are affecting the results of your dataset, of your data analytics task. The second factor that I would like to point out is the data availability. We tend to assume that data availability means that the data is there, we can browse it, copy it, store it, or modify it. But this is starting to be a rare case. Most real-world data nowadays come with some privacy restrictions and confidentiality issues, which means that we cannot simply see them, or we cannot simply share them or sell them. And I believe that in the years to come, we will start seeing less and less of data being available for free or for a fee, which naturally brings the question, what is the future of data marketplaces? Well, my answer is that they need to adapt in order to survive in this new reality. And instead of offering data for sale, they should be offering services for sale. This means that instead of accepting queries and returning data sets, what the data marketplaces should be doing is that they should be accepting requests about tasks, process the tasks locally, and return the results of these tasks. And then the value of a data set is based on what kind of services can be answered on this data. The third point that I would like to make is about the data linkages. Asterios already mentioned it about the importance of linking data sets, because the information is rarely concentratedly or found in one specific data set, but is found scattered across many different data sets. Now, we tend to look at the data linkage as a one-step process, which we do at the beginning, and we keep the linkages for the rest of the lifetime of the marketplace or the data sets. But the truth is that these linkages are not always static. They are not, but they depend on the kind of information that we are looking in the data sets. So they are context dependent. So in the past, what we have done, we have looked at ways that we can infer the importance of a linkage based on the query that the user is posing on a data set. And this means making the linkages context dependent. In a more recent project, which we call Miraculous, we are extending this work, and what we are considering are knowledge graphs and also machine learning techniques, in which we are trying to understand what exactly is the task that the user needs to perform, and based on this we can infer not only what data sets are related, but how they are related to each other. So I think I will conclude my presentation here. So just to sum up, what the points that I would like to make is that in order to accurately evaluate data sets in data marketplaces, we have to consider task-dependent data quality. We have to consider data marketplaces as offering services and not just data. And we have to consider linkages that are context-dependent. Thank you. So Asterios, I think, can give you the floor now.
Yes, and Ziavash Abidjan will take the floor now. Thank you, Yanni.
Okay, thank you very much for having me here. My short presentation will pretty much line up with everything that Asterios and Yannis said before me. So I will just have a quick view on the operations that Asterios already mentioned. But before I go there, just a clear, just a quick distinction that when we talk about operations for finding related data sets, we have several situations to consider. Like the first thing is typically these operations were designed to work in places like data lakes where you don't know what data is available, and when you hope that something useful is inside it. And the same techniques can be also applied in marketplaces where you have curated and cataloged data with rich metadata. And somehow we expect still that using the data available in these places, you can generate some value. Either you have a hypothesis that you want to test as a scientist, or you have a machine learning task where you need to improve the set of features, or you need more data points to improve your model, or there is some business need to analyze some sort of supply and demand about the real world. The typical operations, Asterios already mentioned it. So he talked about Uniable and search for unionability and joinability. I have a simpler one as well. So a very simple operation that you want to have in these kind of situations is keyword search. You're looking for data sets that contain a very specific type of information. Now everything else would go through browsing, right? The other two are the interesting ones from the research perspective, because if you are looking for union and tables, you need to make a comparison between a table that you have. So you already have some data that you're interested in, and you want to see how it fits with data that is outside, that you can connect with. Either you add data vertically by adding more rows and unioning other tables. So you need to check whether the dimensions of your table somehow fit the dimensions of tables inside a marketplace or inside a data lake. And that's a costly operation for which you need proper indexes and a proper way to sift through millions of tables. Or you want to add more columns. That, for example, this is a typical case when you have a machine learning prediction task. We had, for example, in the past, the situation where we wanted to use pollution data, air pollution data that was created through that was measured by sensors, but we only had the location and the values and the dates of the emissions from the sensors. So that would not help us to analyze the causes of air pollution. For that, we would have to add other related columns that are somehow joinable either with the location or with a date, and can lead to improvement of our model. Now, this is a complicated task. You need to see many data sets for that operation, and how you want to address the cost, because everything being attached, and how you want to make it efficient is an interesting research problem. So there are two major problems. The first thing is, how do you formulate the discovery task, especially since the user does not know the scope and content of the data lake. You could do browsing and keyword search, but you probably will not find exactly the data set that you need that combines with the data that you have in production. You could go again example-based, that's like just generalizing the keyword search and try to build your data set somehow by synthesizing data sets that you have inside the lake. That's an interactive try and error discovery. And you might want to also define and enforce quality metrics that are important to you while you're looking for data sets. So if you have multiple data sets that fit your need, you have maybe additional constraints, such as check like the demographic parity of the entities in the data and give me the one that has a fair distribution of data points. And I already mentioned the other challenge is with regard to the efficiency of the operations. What indexes do I need if I want to compare data sets with regards to quality metrics and with regards to table inputs? And can I trade off precision and recall, right? So what is important for me? Do I want to find as many possible candidates as are in the data lake, or do I want to have the best data set and be quickly done with it? So we have done simple steps towards the second challenge. In particular, we have worked on a system that tries not only to find tables that are joinable, but also contain features that correlate with some sort of features that I have already in my data set. And this is a difficult task because initially you need to do first the joining part. So you need to do the difficult part before you can check whether there are other attributes that are useful. So we introduced some tricks and techniques on how to make the correlation calculation on the fly before you materialize the join, and so that you can also measure correlations that require sorting of the data set, which is a expensive operation. The other problem is if you go for joinable tables and you have one join column, you typically will find many tables that are joinable. So it is recommendable to look for other filter criteria that can be used to filter tables up front. That's what we do with multi-attribute table extraction that we have recently developed. So here, the task is to figure out which tables are joinable on multiple attributes. And this is a difficult task because in order to make that efficient, you would need to, in theory, have an index for every combination of attributes on tables in your lake, because you cannot upfront know what kind of join keys you will use, right? And that's something we work on by providing a generalized way of creating the key through a hash function. So that's just some input for the background that we are interested in and why data discovery is hard, also when it comes to marketplaces, because you have to assume that the data is not just a black box that you go and buy, but it has to somehow fit your needs. It's like going to a shopping mall and trying to buy clothing that fits you, right? So you need to try the clothing before you buy it, right? So it's the same. It's the data, only that the time for checking whether the data is useful for your needs might be costing resources. We have a vision to combine all of these approaches in a way so that the user can do this search interactively, and there is a possibility to synthesize tables. For that, you need the appropriate indexes and the formulation metric. About pricing, I have to frankly admit that I have not done research in that area. I just put some thought about it. In particular, when I think about if I build the technology that improves the data set, as described by Yanis, how would I think about the pricing, right? Of course, the effort has to be somehow priced, right? So effort is data transformation, is data added value. Yeah, somehow we assume that the price of a transformed data set should be higher than the price of the data set because we have the data set plus work done on the data set. Similarly, you can build an axiom saying 2 transformations on the same data sets make the data set more expensive than the first one. And the integrated data set should also be more expensive than the individual data sets because, again, there is work. And this is kind of like a Marxist view on creating prices for data sets, because we don't look yet at the final usefulness for the customer. We're just calculating in what is the amount of work has been done on the data set. So in contrast to that, you could really look at the demand and supply, like how you can reach equilibrium with, as Asterio said. So basically, we assume that the demand will regulate the quality and the price. So if people are interested in quality, the price for transformations will be calculated in. And the way to think about it that both views kind of can come together here is that raw data without supervision, without verification, without manual improvement or even automated improvement will create costs on the customer side, because all of that has to be done by the customer. So there is likely that in this particular case, in data marketplaces, we have really the situation that transformations that are curated and integrations that are purposely done will generate more value and will be costlier than the original data set. Now, there are a lot of other questions of what if I can reproduce original data sets from the integrated one? Should these aspects be considered as well? But that's beyond the scope that I can discuss at this point. So I hope with that I have given some thought and some creative thought for the discussion, and I can give the stage further to the next speaker.
Thank you, Zebas. Matteo?
Yes. Hello, everyone. Let me share my slides. Okay, here I am. So thanks again. Very, very interesting discussion, and I will put an effort in giving my opinion on these matters. And of course, we're talking about big data, and we have this idea, right, that when we have a lot of data, we can get a lot of power out of it, a lot of information, a lot of advantages. But the reality sometimes is a bit different. That a lot of data feels more like this, that we are drowning, and we are drowning in data, but not drowning in information. We are not getting the information out of it. So that's the question, right? Even in a data marketplace, how do we get anything useful out of it? And my main message here is that by itself, just having data is not enough, and the data marketplace should be able to provide information, but the information cannot stop at the data catalog. It's not realistic to think that we can just look at the cover of a book and understand if we will like the book, right? The same should be with anything else. So my answer to get over and beyond the data catalog is in 3 steps: the need of big data discovery and exploration, the opportunities of semantic data, and then when we combine this semantic data discovery and exploration. And of course, the data management use case is this new opportunity where we are trying to integrate data from many multiple sources. But there is an issue now that we don't know what data do we have, we don't know how it is collected, and then how to get the information out of it. So this is different data management use cases, right? Because as new people have access to data, then they are data novice in a way. So even if they are technically skilled, they don't know how to get the information. This typical case, we need to find prospective accounts to do an upsell, to provide them a better service. How do we find them? We know that information is somewhere there, but we don't know how to describe it, how to retrieve this information. And that is the case that is common every day. Data discovery and exploration. This is, of course, sometimes manual, sometimes gradual, sometimes long process, where we don't know what we are going to find, but we are starting somewhere and we are getting more information during the process as well. And there are many different needs. One is summarization and profiling, because we need to get information in general about the dataset we are looking into. One is the analytics, so we're trying to get some overall information. And then finally, there is the exploratory research, where we actually dig into the data until we find the information we need. And when we search for a data set, then in those cases, we are still talking about the data exploration. And my view in this is that we can answer this question if we use something that is natural for human, which is providing examples, because we don't start from a blank slate. We have some bit of information that we know already is relevant for us. We know some past accounts that we did a successful upsell, for instance, or we know what is our target marketplace and so on. So we have some basic information. So the data marketplace should be able to give us the other data set, the other data that is relevant for us. So if we can allow this to provide the example in place of a hard query and let the data store, let the database provide the relevant answers, that is one of those services, as Yanis was saying at the beginning, right? That a data marketplace can really provide value there. So how can we do this? And this is where semantic big data can take a role. And for semantic data, I usually talk about graphs and knowledge graphs because they are flexible and because they are powerful and because they do not assume a lot of information behind the schema or the data and so on. In a graph, we have node, edges, relationship, and they can be rich on many different types. We can annotate them with attributes, with descriptions, with ontologies and taxonomies. And there are many different models, of course. I'm not taking a stance here. Property graphs, RDF, they are all valuable and flexible models, where what is important here that the connections provide the information, the core information that can give us answers. So this is the point, right? They are flexible, they can adapt to the data and then can evolve with the data. And they are used everywhere, and that's the proof of their power, right? From product interaction, customer and social networks, so on. So when we have semantic data, then we can move to the semantic data discovery and exploration. And of course, in the modern data management, we have data owners that have different data as products that they provide, and then they need to be integrated, right? And we still rely on data catalogs, but this is very hard. And of course, we can move to data mesh when we have peer-to-peer interactions, but still, how do we know which peer to interact, to which person we need to extract the data and get the data we need? This is still a cumbersome manual process. So instead, mediating through a knowledge graph where entities that are shared and agreed upon can be linked, and this process of linking of data to knowledge graphs can be automated a lot. So the human effort is just the last mile. That is my vision here. And this does not require a full centralization. We just need to talk more or less the same language across some core entities and concepts. And then in this way, we can provide our data instead of a query and get out of the data lake, out of the data marketplace, the relevant data. So relatedness, proof of relatedness, the knowledge graph can provide this answer. And this can be also proof of value, because if you can prove that our content and their content match, then we can prove that we are providing relevant data beyond the cover, the data catalog, the simple description. So this is my vision in this way. Data marketplace as semantic data lakes as a tool where we can actually find what is relevant, not based on the cover of the data, but on the content of the data. Thank you very much.
Thank you, Matteo. Can Zebas and Yanis also turn on the cameras, and I'll try to summarize what I have heard and kick off a discussion. Let me start with Yanis. So one important thing that I have gotten from his talk is that basically linkage is context dependent, which means, Yanni, would you like to elaborate a bit on that?
Sorry, I was muting. Yes, so the idea is that the decision of whether we link to different parts of two different data sets depends on what exactly the user is looking for, which I think this is also related to one of the questions that I see in the chat that is talking about how we can receive the value for a customer, which depends. We have to try to understand from the query what the customer wants, how the customer is planning to use the data set, and based on this we identify whether we should consider a linkage or not. Now we can look at the query, but also what the customer is asking, but also we can use some metadata. We can ask the customer or the user to provide some additional metadata information about the intended use.
So basically, you want to say, if I see through the lines, that the same data can mean different things for different people, and then it should be task dependent on what part of the data and how this data is going to be linked to the original data.
Yes. So the fact that it's the different piece of information means different people, means different things for different users. This is already known from the old data integrations. Now we can take this concept and extend it to the linkage part to say that also the linkage are context dependent. Yeah.
And how does this affect value? I mean, pricing at least. Because again, some people might get zero value from something which is extremely valuable, and vice versa. So,
and because it affects, because at the end, the decision of whether some linkages should be considered or not affects what will be the final product that will be returned to the user. So that's how it affects the price.
Totally. Zebas, I liked the inequalities and your figures there. So you basically claim that data on which we have put effort should cost less, more than the original data set, with which I tend to agree, unless somebody actually destroys it with their effort, right? Which actually takes me to your second claim, which is data should basically get its value from what people think the value is, which is how everything works in reality, right? In the real world. However, can you imagine a way to automate or recommend prices to data producers according to what they submit to marketplace, or have you done any thought on this?
I would have to guess to answer this question, right? So for sure, everybody wants their costs to be covered, right? So that's something that needs to be addressed. In particular, if the transformation is happening online, then you need to think about how to allocate resources online to be able to carry it out. But on top of that, I think that will be maybe the lower bound of the price. I have no clue. This is like something business professors should talk about, right? So I can just guess that I, as a software engineer, I want to have the money for the work that I did, creating the algorithm and running it on the machines. But on the other hand, it might be that some data sets pay for other data sets as well, right? So they are subsidizing other intents so that you can cover a larger crowd of people. But I cannot go into more detail about that.
Totally. Also, you mentioned that we can use correlation as a similarity metric among data sets, which is a very intriguing way to see it. Because so far we have seen semantic relationships or relationships among values, how similar they are, I mean, themselves syntactically. Correlation-based similarity metrics. Do you think these can indeed lead to better machine learning models built with the combined data, or why would correlation be a good indicator of similarity?
Yeah, definitely. I mean, so we look at it in a two-phase way. So we basically separate relatedness from relevance, right? So everything that is joinable because it has tuples that match tuples from my input table is somehow related. I can join it. Now, it depends on whether I do the joins semantically or syntactically. That's up to my decision, right? But after that, the question is, what about the other attributes in the data set? Are they relevant for me or not? Similarity is kind of awkward because I want maybe additional features that improve my precision and recall. And we did some experiments showing that if you add more columns that diversify the feature set that you have for the final machine learning task, you will get better results. And of course, the question is, why correlations? Now, there are some machine learning models where correlations are foundational in creating the relationship between the features and the target value. So that's something we consider in that. So it's a two-step way of thinking about the data set.
So what you mean is that you will take, instead of having a semantic similarity, you will do the hop of joining by trying to bring in some columns associated with a correlated column with what you have already.
I'm not saying instead, I would say on top. Like first you do the linkage, right? So it's up to you whether it's semantic or structural as equality join, but afterwards we do the correlations with the remaining attributes that are coming with the table, because those are the interesting data that I'm interested in.
Yeah, exactly. Excellent. Okay, we have a question from Alberto saying semantifying the data means that everybody share compatible semantics. What is the cost, if possible? Is this cost going to be paid by the clients? Matteo, would you like to tackle this?
Sure. Yes, that's a great question. Actually, there are two parts of this, right? So on one side, when we buy anything, we need somehow proof that what we are buying adheres to some minimum standards, that provides some minimum quality guarantees, anything like that. So the producer should pay this part to prove the value of the data. But of course, then if the customers need to say, okay, I have this piece of data and this, please answer the question, what data are relevant to this? There is some semantification there, right? And we need to make this as cheap as possible and as convenient as possible. And that's where my research works is towards too. So I believe that it's possible to make this as automatic as possible, even if, of course, imprecise and probably noisy, still getting 99% of the way there and leaving the 1% to the human effort is already 1 order of magnitude, 2 order of magnitude easier, right? So I do believe that this is possibility to reach.
On the other hand, the problem with semantics is that people might disagree on the semantics. I mean, the whole thing about semantics is that if you automatically generate them, people will disagree. Even if you generate semantics with people, people will disagree. So is this something we can automate, you think, or should we, I don't know, help people do it easier?
So I believe that sometimes is when we disagree on semantics, in my experience, I work with people trying to semantify data and so on. When we disagree on semantics, most of the time we disagree on some nomenclature, some labels, some terminology. But in the end, we are all referred to the same concept. So it's like saying we're speaking different languages, but we are talking about the same topic. So I believe that sometimes it's just a matter to providing enough context so that people understand what they're talking about. And we have seen this over and over again. I mean, each one of us now can go on Wikipedia, and that's a global crowdsourced source of information, right? And somehow people agreed on what is on each Wikipedia page. Of course, there will be a disagreement for some issues, right? But overall, the big bulk of it, of the information, we can agree upon, and this can be made automatic actually at some point, because I think machines already prove entity linking, recognition, NLP. Now we have these big leaps in understanding text with these big models, right? And this is just basically understanding how a lot of people talk and use text and so on. So I think it is possible, yes.
I see. Okay, so with regards, we have 2 questions about customer perceived value, with which I'm not very familiar. We have 2 points there. If 2 datasets will have a completely different value for 2 different customers, what should the price be? I mean, the easy answer to this one is, I mean, if that was a tomato, how would I treat it? I mean, if somebody really wants to pay more for a tomato, I'll just sell it to the one paying more. So that's one thing. Anyone that wants to add on this one?
Yeah, I can try to answer this, because this, I think, is consistent with, again, what we are selling. If we are selling the product, yes, we end up in a situation where we're selling the same data set at different prices to different people. But if we change the model, as I was saying in my talk, that what you are selling is the service, what we say to each of the customers is, yes, tell us what you want to do. We apply it on the same data set, and what we return is, because the reason that they have a different value and different cost is because they want to use it for different purposes. So if we have the service instead of the actual data, then I think this will be compatible with what is described in the question.
So to answer to the question of Spiros that he's asking below, if 2 commercial products can have different prices depending on the client and whether this is possible or allowed in the free open markets, I think what Jens just said is that if the data marketplace keeps the data to itself and offers services, this is possible. And then, of course, yeah, maybe not extremely honest, but you can basically sell exactly the same service for 2 different prices to 2 different customers and hope that they will never find out. And this, as far as I know, is allowed, and it's not illegal. Anyway, good. Now we have a question from Albert about what are the criteria to identify joinable tables. I can answer that very fast. You can have similarity in the names of the columns, which is a very cheap way of finding joinable tables. You can look at distributions of values and whether those match. You can look for large value intersections among columns and see that those match. You can even use knowledge graphs and all the above information to basically do multiple hops and find similar columns. And with these, we should start to wrap up slowly. Any final remarks? No?
Somebody.
Any questions? Let's see if anyone writes on the platform. Okay, so I'll assume that we don't have more questions. Thank you very much for the insights here, Mateos, Evas, Yanis, and Andra. I learned things. I hope that you did the same, and I hope the followers also learned something today. Thank you very much. We can close, I think, the session and see you around.
Thank you.
Thank you very much. Thank you for having us.
Thank you.
Bye.
Thank you.
Bye-bye.